Hi everyone, welcome to the next video. This video will cover topics on ratio and proportion. So when I cover topics on ratio and proportion, here I'm talking about, in this part, I'll be talking mainly about proportion. We've earlier put up a video which is about only ratios. Okay, so let's understand what is proportion. What do I exactly mean when I say four terms are in A, B, C, D are in proportion? What does this exactly mean? Now, when I say A, B, C, D are in proportion, right? It simply means A upon B is equal to C upon D. That is the meaning of A, B, C, D and proportion. That means whatever ratio A has with B, that same relation C will have with D. That means suppose if A, just for example, if A is double, over here, if A is double of B, then I will know that C is also double of D. Right? That's the part meaning of proportion. What else can I get? If I cross multiply these two, I will get AD is equal to BC. I will get A multiplied by D is equal to B multiplied by C, which is also a very popular thing called as product of the means is equal to product of the extremes. That means in these four terms, A and D are called your extremes. So product of the extremes A into D is same as the product of the means, that is B into C, where B and C are called the means. So remember, for proportion, I always need an even number of terms. I can never have odd number of terms in proportion. Okay, so if I have 6 terms, I can say A upon B is equal to C upon D is equal to E upon F. This can be in proportion, but it can never be in continual proportion. It cannot be, 5 terms cannot be in proportion. So from the next part, we come to what is continued proportion, right? When I say what is A, B, C are in continued proportion, then we can say A upon B is equal to B upon C. That means the term repeats over here. A upon B is equal to B upon C is called continued proportion. Here, if I cross multiply, what will I get? I'll get B square is equal to AC. That means if there are 3 terms, say X, Y, and Z are in continued proportion, then always the middle term ka square will be the product of the extremes. That is X into Z will be equal to Y square. So just for example, suppose if I give you a question that 4P and 9 are in continued proportion, then can we solve this? Can we find P? Yes, we can find P very easily. I'll get P square is equal to 4 into 9. I'll get P square is equal to 36, and therefore P can become plus or minus 6. Let's now concentrate on only 6. It can be plus or minus also. There is no problem over here for it being minus also. Okay, the ratio will still remain same. Suppose even if it was minus 6, then 4 upon minus 6, which actually will convert to negative of 2 upon 3, is same as negative 6 upon 9, which is also negative 2 upon 3. Right? Both the ratios are equal. Now, when you will do continued proportion, you will also understand later when you do the chapter of geometric progression that continued proportion is similar to geometric progression. Continued proportion is same as geometric progression. So 3 terms are in GP and 3 terms are in continued proportion, more or less mean the same thing. Right? So we say over here B is the mean proportional between A and C. Next. Now, can we have 5 terms in continued proportion? I can have 5 terms in continued proportion also. I can have A upon B is equal to B upon C is equal to C upon D is equal to D upon E. And normally such questions, when you need to actually solve them, then the best part is you can actually take this as K and you can get a relation between them. You can take D is equal to EK. Now pay attention. D becomes equal to EK. C actually becomes DK. But because D is EK, I can write C as EK square. B is CK. So putting the value of C over here, B becomes EK cube and A becomes BK. So actually A will become B into, that is EK cube into K, that will become EK raised to 4. So therefore, these 4 terms, that is A is equal to EK raised to 4, B is equal to EK cube, C is equal to EK square, and D is equal to EK. This will be a standard property which you can remember when you will have questions around this, right? Or you can use it as ratios and solve depending on what is asked. Now, next, can we have even number of terms in continuous proportion? No problem. You can take A upon B is equal to still B upon C is equal to C upon D. And if you're using the method of K over here, okay, this will be dk, this will be dk square, this will be dk cube. So I can start with A will be dk cube, B will be B will be dk square, and C will be only dk, right? Let's continue further. Let's understand, you've heard this in school days a lot. What is componendo, dividendo? How do you use it? What is only componendo? What do you get in only componendo? And so on. So let's start. Suppose if we have four terms in proportion, if A, B, C, D are in proportion, and if I apply componendo, remember when I'm applying componendo, I'll have to apply it to both the sides. I can't just apply it to one side. So when I apply componendo, what will I get? I'll get A plus B upon B will be C plus D upon D. This is the application of componendo. The numerator adds basically A plus B upon B is C plus D upon D. You should always just check. For example, 2 upon 3 and 4 upon 6 are same. So after applying componendo, do the ratios still remain same? Let's check. So what will happen? If I add the 3 on the top, this will become 5 upon 3. If I add the 6 over here on the top, this will become 10 upon 6, which is also equal to 5 upon 3. That means application of componendo does what? Just adds the denominator to the numerator on both the sides. You can't just do it on one side, remember. Same thing if you're doing only dividendo. What happens with dividendo? You will subtract. So you will get A minus B upon B is equal to C minus D upon D. And that is dividendo. That is application of dividendo. There are some other terms also which you might need to know, and depending on your usage. What is invertendo? Invertendo is just inverting the ratios. This is not really very important, because if A upon B is C upon D, we should easily understand B upon A is equal to D upon C. That is invertendo. Okay. Next is alternando, which a lot of people make a mistake in. What is alternando? If A upon B is C upon D, we can actually write it as A upon C is equal to B upon D. That is alternando. I've alternated B and C. How does this work? See, even before doing alternando, if I had cross multiplied, I'm getting AD is equal to BC. And even after applying alternando, if I cross multiply, I'll still get AD is equal to BC. That means alternando is proved, kind of. Okay, let's go to the next one. What's application of componendo and dividendo when we are applying both of them? If I'm applying componendo and dividendo both, it will become A plus B upon A minus B is C plus D upon C minus D. This is applying componendo and dividendo together. So we'll have A plus B upon A minus B is C plus D upon C minus D, right? That's componendo dividendo. Let's move to some examples using all these things. So first one, I know A upon B is 2 upon 3 given to me, and I want to find 7A minus 5B upon 7A plus 5B. I'll show you different approaches for these type of questions. First, let's understand how to actually use componendo dividendo over here. With A, I want 7, and with B, I want 5. That means I should do 7A upon 5B. That is, multiply the first left-hand side, I multiply by 7 upon 5. I can't just multiply one side. If I multiply left-hand side, I'll have to multiply right-hand side also. So I'll get 2 upon 3 multiplied by 7 upon 5. That will become 14 upon 15. Now, if I apply componendo dividendo, what will I get? Let's understand. Let's not worry about what they've asked. Let's apply only componendo dividendo. So I'll get 7A plus 5B upon 7A minus 5B will be 14 plus 15 upon 14 minus 15. Fair enough. So I get 7A plus 5B upon 7A minus 5B is 29 upon minus 1, which is minus 29. Right? 29 upon minus 1 is minus. So I've got this much, but this is not what is asked. They've asked the exact thing in the opposite ratio. So I can apply invertendo. You don't have to know invertendo, but you can just say, yes, I reversed it. That means if I reverse on this side, it will reverse on the other side also. Negative 1 upon 29. Now remember, the negative sign does not, in a ratio, the negative sign does not belong to the numerator or the denominator. It is like a common sign. You can write it here also. You don't need to write it here, right? So you can write it as negative 1 upon 29, 7a minus 5b upon 7a plus 5b. This is one of the approaches you could have used. What else you could have done? Okay. So finally, if you've seen the previous video on ratio, when I say a upon b is 2 upon 3, it simply is a ratio b is 2 ratio 3. I can take a is equal to 2k and I can take b is equal to 3k and I can just put it in the question. So 7a will become 7 to the 14k minus 5b will become negative 15k upon 7a will be 14k plus 15k. We'll get minus 1k upon 29k. Kk cuts out and we get negative 1 upon 29. This method, a lot of people say, sir, I can put a as 2, b as 3 also. Yes, most of the times you will get the right answer. But that one catch where the examiner wants you to trap you, he can trap you. So only if the kk cuts out, you know you've got a whole number answer. If the kk was not cutting for some reason, then you can't get an answer. That's very important. Let's see the next sum. We've been given a particular ratio in a 3a plus 5b upon 3a minus 5b. Till this is same, numerator and denominator have same 3a, 3a, 5b, 5b. I can apply component. This time I want to find a upon b. So how do I go about finding this? Apply componendo dividendo. You will get numerator plus denominator upon numerator minus denominator. And this will become 5 plus 1 upon 5 minus 1 on the right hand side. So if I solve this up, in the numerator, I'll get only 6a. In the denominator, I'll get only 10b is 6 upon 4. Now, I want to find a upon b. That means this 6 upon 10, I don't want on this side. So it's as good as taking it on the other side. So when you take it on the other side, the sign will change. It will become division. So a upon b is 6 upon 4 multiplied by 10 upon 6, right? Because I took the 10 on the top over here and 6 down over here. So 6 can cut. 2 2s are cuts, 2 5s are cuts, and I've got a upon b is 5 upon 2. This could be one way of doing this question. What is the other way you could have done this question in? One other way you could have done this question in was you could have actually simply cross multiplied. Let me give you that method also. If I simply cross multiply, I'll get 3a plus 5b multiplied by 1 is equal to 5 multiplied by 3a minus 5b. If I open this brackets up, I'll get 3a plus 5b is 15a minus 25b. Bring all a's on one side, all b's on one side. 3a minus 15a. So it'll become minus 12a. And minus 25b minus 5b. That will become minus 30b. I can cut the negative out. I want to find a upon b. So a remains here, b comes down from there. 30 remains on the top, 12 comes down. Okay. You can cut with 6, 6 5s are, 6 2s are, and we've got the same answer, a upon b is equal to 5 upon 2, right? So different approaches you can use for this. Next, if a upon b is 11 upon 10, we want to find 3a plus 2b upon 4a minus 5b. This time I cannot use component or dividend because I will not get the same thing. So hence over here, you should use the other method which I taught you. A can be taken as 11k and b can be taken as 10k. So a will become 11k. So it will become 3 into 11, 33k plus 2 into 10 will become 20k upon 3 11s are again 11 4s are will become 44k minus 5b will become negative 50k. Let's just go through this one more time properly. 3 11s are 33, 2 10s are 20, 4 11s are 44, 5 10s are 50. So we've got 53k upon negative 6k, except k, nothing else is cutting. So your final answer is negative of 53 upon 6 as a ratio for this answer. Right? I hope you understood why we could not use componendo dividendo, because the same coefficients were not there. Numerator at 3a and 2b, while denominator at 4a and 5b. So we cannot use componendo dividendo. Similar to what we've done earlier, let's just understand this again, because the numerator and denominator do not have the same a and b. I can't use componendo dividendo, and I will just use the cross multiplication method. So I'll get 10 multiplied by 2a plus 7b is 11 multiplied by 3a minus 5b. So I'll get a 20a plus 70b is 33a minus 55b. Let's bring all the a's on one side. So 20a minus 33a will give me negative 13a, and negative 55 minus 70. That should become 125. Negative 125b, negative negative cuts out on both sides. And I'll get a upon b as 125 upon 13. Right? I hope people are getting this. Easy questions, but just understand these are for people who want to understand the basics. Why when 13a is 125b, how b comes down over here, why 13 comes down here, all those things become important. Let's take the next question. M plus n upon m plus 3n, that is not b, m plus 3n is 2 upon 3. Find the value of this part. Now this is a slightly different question. Again, anyway, the coefficients are not exactly same, so I will not use componendo dividendo. I'll use cross multiplication approach. So I'll get 3m plus 3n is 2m plus 6n. 3m minus 2m will become m. 6n minus 3n will become 3n. So m is 3n. Now I'm showing you maybe a different approach completely. We want to find this whole thing. Let's just put m is 3n throughout the question. Let's do this. Wherever there is m, you can still write ratios, you can use k method, no problem. But I'm just showing you a different approach. So one method you could have done was m upon n is 3 upon 1. Take m as 3k, n as 1k and do it. Or just put this in the question. So n will remain n. This m will become 3n. So 3n multiplied by n. N into n will be n square. So 3n square. And 3m square. The 3 remains as it is. M square becomes 9n square. So this will become m is 3n. Right? So m square will become 9n square. So into 9n square. So we've got 2n square upon 27 plus 3. 30n square. N square cut. Answer is 2 upon 30, which is 1 upon 15. As I said, you could have done the k method also. Put m as 3k, n as 3k. At the end, k square would cut. Same logic. Let's see some more ratio question. Find the number which bears the same ratio to 7 upon 33 as 8 upon 21 does to 4 upon 9. That means suppose there's a missing number x. What they're trying to say, x ratio 7 upon 33 is same as 8 upon 21 ratio 4 upon 9. Ratio is division. So if I want to change division to multiplication, it will become x multiplied by 33 upon 7 will be equal to 8 upon 21 multiplied by 9 upon 4. Let's cut on the right hand side how much ever we can cut. 4 ones are 4 twos are 8. 3 threes are 3 sevens are. So I've got x into 33 upon 7 is 6 upon 7. You can take 33 upon 7 on the other side. It will become 7 upon 33. 7, 7 cut. We can cut with 3 more. 3 11s are 3 2s are. And we will get the number to be x is 2 upon 11. That means 2 upon 11 ratio 7 upon 33 is same as 8 upon 21 ratio 4 upon 9. Let's just check that logic. So what is 2 upon 11 divided by 7 upon 33? That means multiply by 33 upon 7. So that's 11 threes are 6 upon 7. And on the right hand side, if you notice also when we had solved it, we had got 6 upon 7. And that's how you can just check your answer. Let's check the next one. What quantity must be subtracted from each term of 9 upon 17 to make it equal to 1 upon 3? That means I have 9 upon 17. I want to make it 1 upon 3. I want to subtract from both the places something. So we'll say let the number to be subtracted from both numerator and denominator be x, right? Now, what will we get if I cross multiply this? One method is cross multiplication. What will I get if I cross multiply? 27 minus 3x is 7 minus x. 27 minus 7 will be x plus 3x. X plus 3x is 4x. And we will get 20 is equal to, that's minus x plus 3x. So that will become 2x. And we will get 20 is equal to 2x and x is 10. Now, a lot of people, when they get this answer, they worry. Say, sir, how can I subtract 10 from 9? Subtract, no, what will we, see, this is a ratio. 9, okay, by the way, there is a small error in this whole question. This question was supposed to be 17, not 7. So we'll have to just change that. I'll just change it over here. So this 27 minus 3x will become 17 minus x. So I'll get 27 minus 17 is equal to still 2x. That part remains as it is. So we'll get 10 is equal to 2x and we're getting x is equal to 5. Sorry. Even if we had got x is 10, there was nothing wrong. We got x is 5. Now, once I got x is 5, I can just check the answer. 9 minus 5 is 4 and 17 minus 5 is 12. And we get 1 upon 3. And that is what we wanted to check. So that's an important part, how 9 upon 17 converts to 1 upon 3. That becomes a very, very important part. Understand that very carefully and then you'll understand, you'll be able to do it easily. Next part is finding the fourth proportional to something. What do you mean by that, first of all? So there are 3 terms given. We want to find the fourth proportional. That means we want to find x. So we can say 1.5 upon 4.5 a upon b is equal to c upon d. So same logic, I can first cut, I can remove these decimals over here. 15 ones are 15 threes are, and now I can cross multiply. So I get 1 into x is x is equal to 3.5 into 3. So x becomes 10.5, right? Simple. Same thing over here. Let's call the last term as x. So I'll get 3a upon 6a square is 2ab square upon x. Whatever is cutting, let's cut. 1a cuts over here. 3 ones are 3 twos are cut. So here I'm left with only 1. 1 into x is x is 2ab square was already there. Multiply by this 2a goes on top. Cross multiplies there. So x becomes 2 to the 4, a square, b square. So that is how you solve such questions. Okay. Let's look at last couple of questions of this type. Find the third proportional to this. That means find x which is where. So when I say third proportional, it automatically means continued proportion. That means a upon b is equal to b upon c. That means b square is ac. That means the square of the middle term, 4 square, is 8 upon 3 multiplied by x. 4 square is 16. 16 multiplied by 3 divided by 8 will give me the value of x. So it will become 8 ones are 8 twos are and x will become 6. Same thing I can do over here. I can take this as x. So square of the middle term, that means a square minus b square ka square is a minus b multiplied by x. Now, we should know the formula for a square minus b square. What is the formula for a square minus b square? A plus b into a minus b. But there's a square outside. That means both of them will become square. Divided by a minus b will become x. So this a minus b one time will cut. So which means I'll be left with x is a plus b the whole square into a minus b. And that becomes my answer for this question. So these are all finding the third proportional. Last part where we are just finding the mean proportional between these two terms. That means this time I want to find the middle one. Okay. X is in the middle. So anyway, we know the formula b square is equal to AC. So in this case, x square will become 6 plus 3 root 3 into 8 minus 4 root 3. Carefully just expand. 6 into 8 is 48. 6 into negative 4 root 3 is negative 24 root 3. 3 root 3 into 8 is 24 root 3. And 3 root 3 into 4 root 3. It's a negative sign. 3 fours becomes 12. Root 3 into root 3 becomes 3. So this becomes negative 36. Right? I hope you all got this. This and this cuts out. So x square becomes 48 minus 36, which becomes 12. And x becomes root 12. Root 12 can be simplified a little bit further. We can write it as 4 into 3. Square root of 4 is 2, and we will get 2 root 3. So I hope you got it. Just expanded it very carefully and solve it out. Let's see the next one. In the next one, I'll get x square is equal to a minus b into a cube minus a square b. Let's take something common in the second bracket. What is common in the second bracket? A square is common. So I'll get a minus b. So I'll get x square is equal to a square into a minus b the whole square. So now when I take square root on both sides, x becomes a multiplied by a minus b. And I agree for both these terms, we could have had the answer as positive and negative both. That means this could be plus or minus. This could also be plus or minus, right? But here the logic was anyway to understand the mean proportional between these two. So with that, we come to the end of this video. I hope you go through this video, understand proportion really very well. Thank you for watching.